anatomy of an AI agent. Now, why am I bringing biology into it? That's a different story. Uh, but talking about what makes AI agentic, one thing which we feel is that there is a goal attached to an AI agent. For a customer support, it could be more like answer the customer's query based on the set of guiding principles. For a coding agent, could be generate code using the prompt given and make sure that there is a testing done for that particular code generated and those kind of things. So it's a very goal oriented thing and it should be autonomous. So there should be autonomy attached to it. So it acts without step by step input. But having said that, the agents should be still supporting human in the loop for critical operations. So something which is very critical, it is better to put autonomy, but with a human in the loop as a you could say check. So just taking care of the customer support. Let's say the agent is autonomously handling the customer, but if there is an escalation happening, or do you see that okay, there's a sentiment that the customer is getting a little bit agitated, there should be a way to pull in a human customer support agent. So it's a mix of autonomy plus human in the loop. Plus, AI agent should be able to reason, as in plan, reflect, and adapt based on the situation. So I'll give you a situation that recently I was talking to a support agent, and that agent was not able to remember what I said beyond two or three answers. So let's say I went to my Udemy agent and said that, okay, hey, I'm facing this issue as an instructor. The agent said, okay, you are an instructor. Sure. Uh, then I said, okay, this is the issue which I'm facing. He said, okay, this is the solution for it. I said, this solution doesn't work. Then the agent said, are you an instructor or are you a student? You understand that it was not able to plan things out. It was not, it didn't have even memory looks like beyond two or three conversation. So that is very important that, okay, it reasons based on the historical conversation, reflect on top of it and adapt based on that. So reasoning and memory both are very important. And plus tool use, for example, Nitesh was mentioning about good experience with Make My Trip. I'm sure that the agent handled the overall situation in a way that, okay, hey, let's say this particular thing has to be done. It was able to make API calls in itself and make the whole flow autonomous. So in a way, mix of these five things, goal-oriented, autonomy, reasoning, tool use, and memory, that makes AI agentic. And just to go a little bit deeper into it, and generally we could say that, okay, an AI agent uses large language model. So AI agent, the first go observes and understands what is the goal, what is the input, and then plans and decide what is the next step. And based on that, in the third point, it acts on those particular steps assigned or actions to be done. And then finally, once that action is done, it goes to the fourth step, which is reflect and learn. Did I complete? Is the plan over? So in a way, it would see that, okay, is there anything else to be done? So there is a loop involved over here. So at a very high level, I would say agent keeps on calling LLMs till the goal is achieved. And it tries to does that observe, understand, plan, act, and then reflect. Now, this was very high level. Uh, Shall we go deeper into how agentic AI loop works? I'm sure there are quite a few senior as well as junior technology professionals in this group. But shall we go deeper into how agentic AI loop works? Say yes or no. Based on that, I'll be going a little bit deeper into it because so far we were talking very high level. Okay, I see few yeses. Okay, let's go a little bit deeper into it. Okay, I hope you can see my screen with a small diagram in the picture.
Yes.
Okay, cool. So this is a very simple Amazon chatbot. Let's say Amazon said that, okay, hey, we don't need agents. We'll directly connect our customers to LLM. And customers talk to that chatbot and that customer asks, suggest phones. And it goes to LLM and gives a generic response. Nothing related to Amazon. So LLM would suggest phones based on what has been the training data for LLM. So this is a very dumb kind of chatbot, and Amazon says, okay, this is not working out to be good. Let me introduce a agent in between. Give me a second. I'm struggling a bit with the Zoom header. Yeah, I found a way to bring it down. Okay. Amazon says, okay, let's actually build an agent. So Amazon comes up with an agent. And let's say this is for the product suggestion agent. And now customer comes to the agent and says, suggest phones. And what Amazon does is it puts a system prompt that this agent provides suggestion on phones. Okay. And in a way, it asks LLM, LLM responds, and the response is returned back to the customer. And when we say LLM responds over here, what is sent is system prompt as well as the user prompt. So this is sent to the LLM. The user prompt is more like a user query, and system prompt is more like a agent's description that, okay, what does this agent do? Obviously, I've oversimplified the system prompt of this particular agent, but it is much more richer in the real world. Now, do you think, or let me rather change it to suggestions on phones sold by Amazon? Now, let's say LLM is trained on what is the historical phones which are sold by Amazon, and it would return the data and it would tune that, but it would still not work out because it doesn't have the latest information about the latest phones sold by Amazon. So that's where there is a concept of tools. Or rather, there's a product tool which is connected to a product service which is connected to product service. Now, certainly agent has a product tool through which it could fetch the products which are sold by Amazon. But how does LLM know that, okay, basically this product tool has to be called? That's where there is a concept of when agent makes a call to LLM, it passes the tools available to the LLM. And LLM could actually say, make a call to the tool or generate final response. So in a way, if you see over here, LLM is given an input in terms of which tools are available. LLM decides which tool has to be called. So let's say in this case, the user said suggest phones, which is more like a user prompt. System prompt is more like this agent provides suggestion on phones sold by Amazon. The agent pushes system prompt, user prompt, as well as tools available to the LLM. LLM says that, okay, based on this user's query, looks like I should use the product tool and fetch the products of type phones. So in a way, when that agent receives that request that, okay, make a call to the product, agent makes the call to the product tool, and then whatever the tool responds, it sends that to LLM. Now LLM could come back and say, hey, make a call to another tool. Then agent could actually make a call to another tool and send the another response which is concatenated to the initial request. So in a way, there's a loop attached over here. So if I could draw a circle over here, so there's a loop. In a way, agent keeps on sending the request to LLM. And if LLM says, call that tool, agent calls it. And if It gets the response, the agent passes that response to the LLM. So that loop in itself is the one which we talked in the previous slide. Now, certainly, let's say in this particular case, after calling product tool multiple times, LLM got the response that, okay, this is the phones which I could suggest. So now it could say that, okay, this is the suggested phones. Okay. Any doubts or thoughts of this particular thing? There are quite a few things missing still. We haven't gone through the full anatomy of it. Anybody would like to say or put it on chat?
Yeah, I wanted
Manpreet,
to
when you said
clarify
this
one thing.
product tools, right? My understanding is we will be having something called a tool prompt, which will have the information about what tools we have.
Excellent. So that's a very good point, Ram, which you have mentioned. Every tool has got a metadata in terms of description, parameters it takes. I'm not, for the brevity of space, I'm not mentioning everything, but it has got description, it has got what parameters that tool takes, what is the purpose of that tool, and that goes as an input to the tools available over here. Based on that, LLM is able to decide that, okay, hey, looks like I should be able to call this tool to fetch data. That's a great point you mentioned, Ram.
Right. So the second one, which I have something, I mean, I have a doubt is, let's say I need to pass in the information of the result of the tool one to the next tool, where the state would be maintained. Is that will be part of a prompt, or will that be an information? I mean, how exactly those states will be carried out?
That's another excellent point. So, based on what I've seen with the frameworks which I have played with, again, it's a prerogative of the framework, which we'll talk in the subsequent slides. For example, when I've used Crew AI, what it does is that the responses from all previous tool calls are concatenated and pushed to every LLM call. So based on that, the LLM is able to make the call that, okay, the next tool call which I have to make, I need to pick up this input from the previous tool response. So that's where I've seen most of the times happening. So in a way, the context is maintained through the context window. I'm introducing another term, context window, because LLM doesn't understand anything beyond the current request. It only understands current request. Probably that was the reason which I mentioned earlier on. It is dumb as well as intelligent. It
Right.
doesn't have any memory. So it would only get to know based on the previous tool responses attached to the prompt.
Sure. So in this example, let's say if someone is looking for a phone sold by
Mhm.
Amazon, let's say there are 500 different varieties of phones listed in Amazon. So the first tool call would get all those 500 different phones with probably some, I mean, attributes associated with those phones, and those will be concatenated into the context for the next possible tool call, if at all, if we need to make.
Okay, now you're saying multi-turn interaction with this particular agent. If I could get your point right.
Yeah, I mean, my question is that the results will be added into the context window as like a string for the next call, right? Or it would be some information. I mean, basically, I'm just trying to see if you just, I mean, call a rest endpoint and get in the results, won't that actually blow up the context window? Because, I mean, it's the database results or something, right? I just want to try to see how in this world, I mean, usually how these things are planned, right? I mean,
Sure,
uh,
sure, sure.
yeah, I
There,
mean,
there, I would try to give two answers to this, Ram. And one answer is more like there is a concept of multi-agent. So which I have seen is that, okay, where we feel that, okay, context window is getting bloated, we could split the agent into two parts. We could say that, okay, the first agent does some step, summarizes the thing, and then the summarized output is passed to the next agent. So we'll come to multi-agent in a while. But the point is that this is one of the solutions which I've seen from the perspective that, okay, from the context window perspective. Or there is a way, for example, if you see Claude Code, Claude Code is a coding assistant and its context window is huge, but not that huge. So there is a feature to do compaction. by which we could compact whenever it reaches 100% of the context window size. It asks me to, okay, it looks like it's exceeding the limits. Shall I compact? I say yes, then it compacts and put the summary in the context window. And but coming to another point, which you brought up, let's say I suggested some phones, and what if the customer says, tell me the rating of top three. Now, when it comes to the agent, now it doesn't understand what does top three mean. LLM doesn't understand what does top three mean, because that whole, you could say, loop was for that specific request which says suggest phones. And that's where uh, most of the agents, they try to put a component on it which is called memory, and that's where it stores the context across turns. No doubt we could store the context even within a particular turn, but generally I've seen people storing memory across turns, across multiple requests. And now if the rating of top three comes, the previous request and response would be stored in memory. It would be, agent would be able to append that memory as part of the request which goes to LLM, or it could summarize that memory based on its behavior. And then in a way, the conversation history would also go as part of the request to LLM.
Hey, Manpreet, a small thought on that. So let's say
Sure.
if we have used a tool in between, the response from the tool or even a previous LLM calls result, if we do not put that into the context window for a successive LLM, definitely that LLM do not know about it, right? So
Yes, that's right.
somehow if LLM call is made, which that is influenced by the previous conversation, we definitely need to add those result into the context window, right?
That's right. That's right. Yeah. Thank you, Harris. Let me go to the chat window. There are two questions over there. Can we assume it is similar to MCP tools? Darshan, very good point. Hold your thought. We'll come to that in next couple of slides. We'll talk about MCP, but a good point. Vibhor says, can you touch upon the context window too? Sure. So in LLM, the context window is the maximum size of the input which could go to an LLM as an input. In a way, what we say is that if we keep concatenating the responses, conversation history, if we exhaust that context window, most of the times the request gets truncated and we would not get the quality response. So it is the responsibility of the agent to take care of, based on the context window of the LLM, basically either summarize it or trim it from the top, not from the bottom, and accordingly push it to the LLM. Vibho, did it answer your question?
I was just curious about, like, is that something a feature of an agent, or is it something a feature of whatever is orchestrating it? Like, I've always wondered, like,
Yeah,
I use GitHub Copilot
yeah.
and I've touched upon anti-gravity, Claude, and whatnot. Every one of these tools, they show a context window.
Mhm.
I always imagine like that to be somewhere. Um, Again, there are two ways. One could be on the GitHub Copilot server, they have stored all of that past interactions. And of course, there's some kind of a storage. I don't know if it is on the file system or is it on the cloud that keeps a track of what really happened. Maybe what were the responses from different kind of MCP servers. Uh, what's the right pattern or the common pattern rather around how do people imagine it? Like when you say, okay, context window, is it just all the past uh, interactions and are you saving it on the file system that you always sent as a part of the request on HTTP? Or is it something co-located with the LLM or somewhere
Oh,
next to it?
got it. Based on my experience, Vibhor, this is, for example, memory, let's talk about. I have used file system memory, as well as there are cloud services like AWS Agent Core memory,
Okay.
which using which I could store the memory of the previous conversations. But having said that, uh, to what extent that memory should be pulled, how should it be sent to the LLM? That is something which is left to the agent definition. Generally, the frameworks would give support of that, okay, hey, do you want to send the memory summary? Do you want to send the whole conversation history? Do you want to send last five and summarize it and send? All the options are available from that perspective. Is the agent configuration which decides that, okay, conversation history should be sent in what fashion? Now, coming to the important point, the loop in itself, the tool's previous responses and everything, I think that is sent verbatim. I was mentioning about Crew AI. In Crew AI, there is no way by which agent to configure that, okay, should I send the complete tool response? Yes, Crew AI always sends it verbatim, the previous tool responses, but it leaves that configuration open where agent could say, hey, whenever the context window is getting overflown, trim it from the top or fail it. So it gives that configuration to the agent. Most of the frameworks does that. I hope that answers your question, Vibhor.
Um, Partially.
Asha.
Okay. Yeah,
Hey,
it's
No, no worries.
it's
Manpreet,
always
Manpreet,
been confusing
I want to
to
ask
me.
one thing on
Yeah.
top of Vibhor. Generally, what you were talking about, Manpreet, how to organize those contextual information. But when we talk about context window, it is completely about the additional space an LLM is offering you, right?
I won't say additional space. I would say it's the maximum size of the input.
Okay.
Right,
So it's
right,
like a
okay.
okay.
It's
That
purely
does
up
make
to
sense.
LLM,
Yeah.
right?
Yes,
LLM
yes,
decides it, right?
yes.
Yeah.
Gemini supports 1 million tokens in the context window. I guess Anthropic supports, if I remember it correctly, somewhere around 256K. So it's in that range, depending upon that particular LLM support.
Can
Okay.
we increase
So
or decrease this memory?
See, context windows. Hey, Dinesh, by the way, hi. Good to see
Yeah,
you
hi.
joining. So yes, LLM is a fixed context window size. Memory in the agent is configurable. It's our implementation. We can do the
Okay.
way we feel like. But the time we are using LLM, that's a fixed context window size. We can't go beyond that. LLM would fail if it goes beyond that. LLM call would fail if it goes beyond that.
through this
Okay.
conversation, I've had one realization that again it's a LLM level detail, and how you implement it or how a tool implements it, that is secondary. The LLM cares about the system prompt and whatever is the prompt input that you give. So if we abstract that out, like let's say if my VS code does something funky behind the scenes, all that LLM cares about is the system prompt, the input. I can give it 1 million tokens, and that's my context window. Is that a good summary?
Yes, I would say yes.
Okay.
Yeah, cool. Cool. Certainly, Vibhor. I think you still have doubts. Probably we'll circle back in one-on-one conversation and we'll discuss it out. Yeah, cool. Thank you, Vibhor. Now, next step. Now, Amazon says, hey, I just want to go beyond product suggestion agent. I want to also support not just products suggestion, I want to support order. That is, user should be able to order based on the request, based on the input to that particular chatbot. So in a way, what I'll end up in doing is that I'll create a order tool that, okay, and there's the order service. And okay, now my certainly product suggestion agent would become product suggestion agent plus order agent. And I would now say system prompt, this agent provides suggestion on phones sold by Amazon as well as create orders. So far it seems good that, okay, it would work, but imagine a situation that Amazon has got hundreds of features like returns, shipping status, you could say ratings, comments. If everything else we try to put in a single agent, the system prompt itself would become diluted to that extent that the quality of the agent would reduce. I'll give you an example. If you go to a human who is Python, C++, Java, JavaScript, Rust, COBOL, every programmer, he understands everything. He or she understands everything. And if you ask to that programmer, hey, write quality code, it would mess up in the output. Similarly, if an agent is given too much work to take care of from different domains, different feature sets, it would literally be very low quality. So generally we say, okay, if there's a human who specializes in Java and that person could go deeper into Java, yes. So generally breadth and depth in all things doesn't come together. With that same analogy, generally an agent scope should be very limited to a specific thing. So we should say either a product agent or a order agent. That's where the concept of multi-agent comes into the picture. And if I see this as one of the diagram which I drew, let's say Amazon chatbot said that, okay, I want to now support multiple kind of features. Now what it could do is that it could create an agent with the name of intent detection agent. Based on the user input, it actually decides which agent should the request go to. It could go to the products agent, it could go to the orders agent, it could go to the returns agent. Now, every agent could have, rather, would have its own LLM. I could have intent detection agent, which is connected to GPT, products agent, which could be connected to Anthropic Claude Sonnet LLM. So it could be any kind of agent connected to any LLM. It could have its own system prompt. It would have its own set of tools available. So in a way, this is one of the example of a multi-agent system where intent detection agent routes the request to product agent, orders agent, returns agent, and more type of agents as supported by Amazon. This is exactly the purpose of multi-agent, to split the agent into multiple parts in a way the similar way we have been doing in past decade or so. Monolith, when growing in huge size, its maintenance was a nightmare, its quality was a nightmare. That's why we landed up in microservices. Similarly, we have got a multi-agent patterns where we split the agent into multiple agents. And in this particular case, we have implemented the router pattern where the intent detection agent routes the request to multiple agents depending upon the query from the user. Now, there could be multiple such patterns. Router is one such pattern which we saw. Okay. I guess we have hit the time limit for this section, but I could take one question if you have on the multi-agent. Anybody has any question on the multi-agent? We'll spend 2-3 minutes on that. No? Okay.
One question.
Yeah, Mahesh.
One question rather, I'm trying to understand. Cloud Code has recently released like skills, right? Skills capabilities. So how my understanding of skills is they are trying to say add the skills to one agent, it will do everything. That is what I have understood, and you don't need the multiple agents. But I'm trying to understand, is my understanding correct, or the skills are totally different from multi-agent model?
No, I think your understanding is, by the way, we are digressing into a little bit into Claude, which is a specific implementation of agents. So I'll probably tell in 20 seconds or 30 seconds what I have observed so far with regard to Claude. So the Claude itself said that, okay, skills are more like a sub-agents, if that is the right word to use. Their main agent could trigger a skill based on the prompt given in the agent. So in a way, it depends on the implementation of the Claude agent, and Claude agent also has implemented the router pattern that, okay, hey, looks like I have to call this skill to actually achieve the purpose. Let's say I have a gamma skill. So this, you could say the skeleton of this slides was created using Claude using gamma skill. So I have that system in place. So skeleton was created, then I added content to it. But in a way, that skill understood that, okay, this is how the visual theme of the slides this person wants. But ultimately, it's a sub agent, Mahesh, if it answered your question.
Okay. Yeah, it answers. Thank you.
Manpreet, I need to add probably 15 seconds for that particular skill,
Sure.
right? I think the one thing which the skills reflect upon us, right? At least people are thinking over. Please do not build any agents, right? I mean, the building of agents is pretty much done. I mean, we were all creating our own workflows for the needs, whatever, explicitly creating all these workflows. But I think the time for that is probably gone. We have a general purpose agent. I think it's available, and people started writing skills on the top of it, so that I think agents can orchestrate whatever the skills has given. So I think the world is heading towards the place where we have a general purpose agent, like let's say like a web browser or something, which everyone will use. And then we will have just the skills attached, like whoever who wants to do anything over there, you just like write it as a skill and give it to the agent. Agent will be able to orchestrate. I think the methodology was we orchestrate the agent's workflow in a code. I think we are slightly shifting towards the world where I think the orchestration itself is done by the general purpose agent based on the skills.
Yeah, I think you articulated it very right. So it says that, okay, the shebang which each agent requires is much more. You create skills under the same agents, which is, they call it sub agent, they call it skills. But thank you, Ram, for summarizing. That's a great articulation. Thank you, Ram.